Hi everyone, it's 9 a.m. so we're going to get started. I want to thank everyone who is tuning in to this webinar. Our topic this morning will be on precast refractory shapes and learning if they will fit into your operation. Our presenter is Mr. Brad McCorkle, Allied's Precast Shapes Manager. Brad has been with Allied for nearly 30 years, has 11 years of experience in the foundry industry, and has been working directly with precast shapes for 16 years. If you have a question during the presentation, please submit it in the Q&A box on the right of your screen. We'll be answering all of the questions at the completion of the presentation. I'll pass it over to you now, Brad.
Thank you, Elise. Again, I'd like to reiterate that we appreciate everybody joining us today for our webinar. And again, at the end of the session, any questions that have been typed into the comments box, we will address those at the very end. And certainly if there's any questions other than that after this is over, feel free to email me or your Allied sales representative or contact at any time, and we'll get back with you as quickly as we can. So again, thanks for joining us, and we'll go ahead and get started. First, I'd like to introduce Allied and our precast shape capabilities. We currently have 7 precast shape facilities located around the globe. That includes 2 here in the United States, 1 in China, 1 in Europe, 1 in South Africa, and 1 in Chile, or excuse me, and a licensee in Chile as well as Brazil. Our precast shapes are available for foundry, steel, aluminum, heat treat and forge, as well as the industrial markets. A quick rundown on what we're going to review today. We'll talk about how a precast shape can give you a faster turnaround, potentially reducing downtime, a quicker, less intense tear out of old refractory, a faster installation, no waiting for material that's cast in place to set or cure, and then a much quicker dry out. We'll also talk about controlling your risk and your variables. That will include reduced training commitments, tight manufacturing tolerances for precast shapes, detailed documentation on that manufacturing process, an indefinite shelf life, as well as no expensive capital equipment that's required for the installation. We'll talk about how we can provide a solution for your precast shape that could help potentially solve a problem that you're having, and then what it takes to get started to get a precast shape into your facility. Reducing downtime. One of the biggest advantages of a precast shape is the speed of tear out. Precast shapes are typically either bolted in place or installed with a dry backup lining. With a dry backup lining, when it comes to the tear out, the material is typically low bond or no bond material, so it's very easy to remove from behind the shape. When you can do that, then the shape comes out with a lot less effort once it's released. Bolt in place applications, those can just typically be unbolted, or at the end of the campaign, the hardware can just simply be cut off for the shapes to be removed. So there's very little need for tear out equipment. The easier removal will eliminate potential damage to your steel shells that could be caused from mechanical tear out equipment. So you have less repair that you may or may not have to do after the tear out's completed. The speed of the installation is also a big benefit of a precast shape. There's no casting forms involved to install or remove, so you have a big time savings there. And as mentioned, there's no waiting for materials to set up after the installation has been completed. Most cast in place materials, you're going to be required to wait about 24 hours, give or take, for the removal of the form. And with a precast shape, you're not going to have that wait time. Installation of a precast shape is also a lot less labor intensive than a cast in place material. So you're going to have a potential savings of injuries and man hour savings there as well. With a precast shape, they're also pre-dried at our facilities prior to shipment. A typical precast shape is dried to anywhere from a range of 6 to 1100 degrees Fahrenheit. We have 7 designated ovens that will achieve that here in Columbus. We also have a high fired oven here in Columbus that if we want to go to elevated temperatures up to 2250 degrees Fahrenheit, we can do that as well. At 600 degrees Fahrenheit, more than 90% of the water has been evacuated. Those, as you can see from the chart here, the majority of your water is going to come off as physical water when it simply steams. That's going to be achieved at 212 degrees Fahrenheit. The first hydrate phase is then going to come off. That's what we refer to as the chemically combined water. So it's chemically combined with the cement. That's going to come off at roughly 450 degrees Fahrenheit. And that's going to be about another 15% of the total water that was added to the mix. At 525 degrees Fahrenheit, an additional 16 or 18% is going to come off. And that is typically all the water that's going to be released prior to you getting the shape on site. If we do go to an 1100 degrees dry out, then at that point you've lost 100% of your water, which includes the last little bit that comes off at about 1022 degrees Fahrenheit. So as you can see from the range here, precast shapes are typically fired in this range that you're seeing. So if we come up to the upper end of that range, the chemical water is all of the chemical water has also been released. Here's a great comparison on comparing a precast lining with a cast in place lining on a 12-ton transport ladle. With the precast system, once the installation is complete, you can immediately go into the dry out cycle or the heat up cycle for the precast shape. It's really simple. It's a 400 degree per hour ramp straight up to approximately 2000 degrees or whatever your operating temperature might be. And then you're going to hold for approximately 4 hours before you bring the shape into service. So it's a very quick heat up, takes about 8.5 hours, depending on the application. For non-ferrous alloys, it's going to be quicker and lower, down in the 1000 to 2000 degree range. With a cast in place lining, comparing the same exact application, precast shape versus cast in place, you can see the multiple steps that you're going to have to go through for a proper dry out. That's going to include a 75 degree per hour ramp up to about 300 degrees where you're going to hold for 6 hours. Another 50 degrees an hour up to 450 degrees where you're going to hold for another 6 hours. And then another 50 degrees an hour up to 600 degrees where you're going to hold for 6 hours, and then so on and so forth. So you can see there's a lot of complexity to that dry out, a lot of steps, a lot of holds, and a lot of controlled ramps that you're going to have to try and adhere to. With the precast shape to 400 degrees per hour, very quick. In most applications, it's pretty much going to be what the heat up equipment is going to be able to do anyhow. So much simpler, much quicker than the cast in place option. Next, we'll talk about controlling risk. What I mean by that is just controlling a lot of the factors that you could have in your process if you're doing cast in place versus precast. With precast, you have a lot less training that you have to go through. There's no training on equipment or mixers. So there's a lot less safety training that you have to put your workforce through. There's also no training on the proper installation or removal of forms. When I say proper installation, that's really key when installing cast materials. When installing cast materials, if you have an application where you have several thousand pounds of material that's going to be installed, properly securing that form is extremely important. If you don't do that and the form moves during the installation, then you've potentially just lost all of that material and you'll have to redo it. So the proper installation of securing of forms is not going to be needed for a precast shape. There's also not going to be any training required on how to properly mix and cast the materials. not only mixing, but also vibrating. You want to make sure that when you're doing a cast-in-place lining, that those materials are vibrated properly to ensure you have as much porosity as you can get out of the material, and to make sure you don't have any voids. So there's no need for training on casting materials for a precast shape, because we're going to take care of that for you. And as mentioned, the dry out is much less time, much shorter, less complex. No need for expensive dry out equipment that has to maintain those critical ramps and holds. You can do a lot of preheat on a precast shape with much simpler equipment, and it's going to require much less time. Minimal equipment is needed for the installation of a precast shape. There's no need for mixers, pumps, and something that a lot of people don't think about when it comes to that equipment is the associated maintenance that it takes to maintain that equipment properly. How many times have you been doing a installation of a cast material and you had a breakdown on a mixer or a pump that could have caused issues? With a precast shape, you won't have that problem. There's also no need to allow for the excess space in your facilities for the installation of cast-in-place materials. The installation of a precast shape really is just going to require enough room for the shell that it's being installed in, if it's a standalone piece of equipment. You know, you may have the need for some space for a forklift or a small crane to install it, but for the most part, you're not going to need a lot of space to install a precast shape. Most installations will only require the use of a small crane or forklift. And then installations with a dry backup lining will require vibration, but that vibration is really no different than the vibration that you would typically do with a cast-in-place system. Most dry backups are going to be installed with a form vibrator, you know, something you clamp to the shell of the equipment to install it. I've also installed precast shapes with the use of pencil vibrators. It depends on the application and the cross section on how much room you have, but you can also install some with the use of a pencil vibrator. Shelf life is something else to think about when you're looking and considering a precast shape. If stored properly, which is basically just a dry area in the plant protected from freezing, if installed properly, shapes have an unlimited shelf life. You can literally keep a precast shape on the shelf for years on end, as long as it's stored properly. And when you pull it off the shelf to put it in place, you're not going to have any issues. With that, you'll have no inventory loss due to shelf life expiration. You know, how many times have we walked through our plants and seen material that was sitting on a shelf that's been there for a year or two or longer? It's, you know, completely covered with dirt. And you question whether or not it's any good anymore, and it ends up ultimately getting thrown away. With a precast shape, you will not have that issue. Shapes can also be maintained in inventory at our allied facilities, ready for an immediate shipment and use whenever needed. We have many customers where we have agreements with that we maintain a specified amount of inventory on our shelves, and when they need it, it's a simple phone call. Put it on a truck and it's shipped that day or the next day or the next shipping day whenever it's needed. So it can be very beneficial to have that inventory available and ready for use. Tight manufacturing tolerances. You know, when it comes to controlling your risk and the lessening the chances of having a bad installation, having a tight manufacturing tolerance is always critical. When we manufacture our shapes, our precast shapes, we document all of our processes very stringently. All of those records are maintained. Set times of the materials that we use are confirmed prior to casting. You know, we want to make sure that when we cast a shape, it's cast one day and stripped the next. So we want to ensure that the set times on the materials are confirmed prior to use. The mixing times are also monitored and recorded. So when we mix materials and it has a specification to dry mix for a certain amount of time and then wet mix for a certain amount of time. We make sure we do that very stringently. All materials are also checked to ensure proper flow. If you look at the video there on the right, it's a simple ASTM flowability test that we perform on every batch of castable that we use that goes into shape. It's a simple test, goes on a table that's tapped 15 times. It's then measured to see how many millimeters of expansion that is created from the 15 taps. And we do that to make sure that for whatever shape we are casting, it has the appropriate flowability to make sure that we're making a good, consistent shape every single time. Material vibration is also timed. All of our mixing stations have timers on them that we use for dry and wet mixing, as well as vibration once the material is placed. So we want to make sure it's vibrated adequately, but not over vibrated. The amount of water, as well as the temperature of the water, are also checked and documented. Any addition of reinforcement fibers, so stainless steel needles, carbon steel needles, if there's any type of reinforcement needle that is being added to the mix, we're going to document that to ensure that it's put in there in every case where it's needed. We want to make sure that shapes are manufactured properly and consistently each and every time. Consistency is very, very important to your operations in reducing downtime. Being able to get to a point to where you can plan relines instead of reacting to an issue where you have to reline is always important. So we want to make sure that when we manufacture precast shapes, we want to do it properly and consistently each and every time. The reduced heat up, that also eliminates some concerns that a lot of people have when you heat up a cast in place lining. You're with a precast shape, you're basically getting no or a very low risk for any type of steam spalling. If the material's gone to a full 1100 degree pre-dry, then you won't have any risk at all for steam spalling. That also gives you less time to monitor gas burners, less manpower to man those burners. So it's a big cost savings in gas consumption by having that rapid dry out. And a lot of places anymore may not be operating around the clock. So if you're operating, if your current operating pattern is maybe an 8 or a 12-hour day, then you don't have to worry about having somebody in the facility overnight to babysit a gas burner in a cast in place system when you can heat it up and get it online within that 8 or 10 hour time frame from start to finish. Precast shapes can also be used to provide a solution. A lot of times with cast in place linings, you pretty much have what you have. So with a precast shape, we can get a little bit more involved with the design of that shape to help you try and overcome a problem. If you're having mechanical issues, Allied's engineering group can work with you to solve a problem, maybe come up with a new design that's going to eliminate some mechanical stresses that you could be seeing. We can also use FEAs, finite elemental analysis, to look at heat losses to determine if there are stresses or buildups that are being created from excessive heat loss in a certain area. We can help design the precast shape around that to try and eliminate that issue. And you can also use lightweight dry vibe materials to back up shapes, which are going to provide you a little bit better insulating environment to help reduce buildup that could be happening due to heat loss. The important thing to remember is a lightweight dry vibe material still provides you with that safety backup behind the shape. So it still gives you that peace of mind that you have a safety lining installed behind the shape to ensure that everybody in your shops are operating in the safest manner possible. Casting direction can also be used to create a lower porosity hot face. What I mean by that is when we make a precast shape, we want to try and get the porosity to work away from the working hot face of the material. What that does is when the air works away From that, if you're using a form that has a taper to it, the air will work away from that tapered surface when it's inverted. So that's why a lot of precast shapes we cast upside down. The lower porosity on the hot face will result in less slag buildup adhesion. If you're looking at precast ladles or applications in maybe cement or lime or minerals processing where you have a lot of clinkers that build up, that lower porosity hot face can help eliminate some of the buildup adhesion that you'll have with a cast in place or a shotcrete or gunned system. That tighter hot face will also promote easier cleaning when it comes time to try and knock that buildup or slag or clinkers off the surface. So there's a lot of benefit that you can have from just having the opportunity to have a good low porosity hot face. High needle containing mixes that are very difficult to install in the field can also be used for precast shapes. Because we have such a controlled environment in our facilities, we can take the extra steps that needs to be taken when you have to cast a material with a high needle concentration. Now there are materials that can be cast in the field that have high needle concentration, but nothing to the extent that I'm talking about. The super high needle containing mixes are just absolutely superior when it comes to thermal shock. If you have a severe thermal shock application, some of those super high needle containing mixes can be very, very beneficial for use. Yes, they are more expensive because of the amount of needles that go into them, but the benefit can just pay dividends to help solve a problem that you might have. They also have great high abrasion resistance. If you have applications where the abrasion is just excessive, then there are a lot of benefits to using a high needle mix. And the strengths of them are just really incredible. The super high needle containing mixes, you know, in some tests, they can be cycled many, many, many times before you ever see any degradation in strength due to thermal shock. So they're just incredibly strong and just far superior when it comes to thermal shock applications. Manpower is another problem that a lot of places are having problems with today. With a precast shape, you know, if you have a manpower issue, then it shouldn't be a problem. Precast shapes take fewer people to install, so they're going to have a lot of benefits with having low manpower. They also have a lot of benefits when it comes to ergonomic situations. You know, when you install a precast shape, there are materials that have to be installed, the dry materials that have to be installed behind the shape. But, you know, in a like this ladle that you see pictured here, the amount of material that goes behind that ladle is probably 1,500 pounds, maybe 2,000 pounds of dry vide material that go behind that ladle. That particular ladle there is a 12-ton ladle. The amount of material that goes into that ladle, if you cast it in place, is probably 6,000 or 7,000 pounds. So the manpower that it takes to place 1,500 pounds of material is going to be much better ergonomically than lifting 55-pound bags to mix 6,000 or 8,000 pounds. So there's a big ergonomic advantage with a precast shape as well. Lowering your overall cost. That's important, especially in today's environment. Reduced downtime is a huge savings in money. I mean, not having the downtime, especially unexpected downtime, can really be costly. The reduced man hours is also a big cost savings. Reduced gas consumption from the shorter heat up. Eliminating the loss of material due to the shelf life issues. You know, as mentioned before, shapes have no shelf life or have an unlimited shelf life if they're stored properly. So eliminating that loss of material due to shelf life issues is always very important. A lower need for expensive material and pumping equipment. If you're in a situation where maybe your paddle mixer, the equipment that you use for cast in place linings is getting dated, needs a lot of repairs, a lot of money put into it, then it's possible that a precast shape would be the right answer for you to something for you to look at. So now that you've looked at everything and you think that a precast shape is something that you may or may not want to look at, then the next step would be defining what you would deem successful for using a precast shape. You want to know what you're trying to accomplish. So set a goal. If you know what you're trying to accomplish, then you can get a better understanding of whether or not using a precast shape is going to be the right thing for your application. If trying to reduce downtime, or you have a manpower issue, and you just don't have the people available to do the cast-in-place linings anymore, then if you know that up front, then a precast shape could be a good solution. So if you know what your goal is, you're going to have a better understanding of whether or not the precast shape is going to be the right direction. If a precast shape can help you achieve that goal, then maybe it's time to look at it. The other thing we can do is design the shape to meet your goal. So if you have an issue with a mechanical stress that's causing cracking of the lining, and you want to look at a different design, then maybe a precast shape is an option for you. If you have issues with slag buildup or buildup of materials on the lining, then maybe designing a precast shape could help you meet that goal. So as long as you know what your goal is, then you'll have a better understanding if a precast shape's the right direction. You want to design the shape to meet your goal. When it comes to designing a shape, existing prints are always a benefit, whether it's a print of a steel shell or the actual application, it's always going to be a big plus. So designing the shape is something that we can definitely help you out with. Field measurements a lot of times will be required. That's not a big deal. We will come to your facility, take the necessary measurements that we need in order to design a precast shape for your application. We have a great engineering group that can help design a custom solution. They do a fantastic job of coming up with shapes designed to help meet specific needs. So we can help you out in that area. And if you think that the shape is something you're wanting to look at, then your allied sales representative can help you get things moving in that right direction. Next, you want to understand and determine the right mold for the job. With precast shapes, obviously there are molds involved for making that shape. It's a little different than a cast in place. Typically if you're casting something inside of a steel shell in the field, you have an ID mold. With a precast shape, we're going to have that ID mold as well as an OD mold if there is a cavity inside of the shape. Determining what the right mold is for the job is important. Steel is a permanent mold. It makes a great shape, very durable. It's a one-time purchase, so it's definitely the best way to go. But it may not be the best way to go right out of the gate. The other option is temporary mold, so a wood or a styrofoam mold. We have the capabilities in our facilities to make styrofoam molds using a CNC hot wire machine. So we can custom make those molds for you. It's much quicker. If it's an application where you don't need just one shape, you might need 100 shapes, then a lot of times a styrofoam mold is the right way to go, because you can make a lot of those shapes in a hurry. So you have less lead time, and it could be something where maybe you only need that shape once every 3 or 4 years. So the styrofoam is more economical to look at as opposed to the steel. As I said, the steel is always expensive, but it's also a one-time cost that's going to be involved when making the precast shapes. So if you have an application where it's going to be the same each and every time, like a ladle or some type of a pouring vessel, then a steel mold could be the way to go. Wood and styrofoam are always the quickest, but not always the correct answer or the right solution. Styrofoam, the great thing about styrofoam is if it's a one-time use. So, you make a styrofoam mold, when that shape gets removed from the mold gets destroyed in that process. So it's a one-time use, but the good thing about that is if you're trying to design an application or come up with a design for a specific application, and you're not quite sure if that's going to be the design that you stick with over the years, then styrofoam can give you a good benefit. We're going to make a mold, make a shape. You can try it. If you want to tweak that design a little bit, then the next time we make it, we can tweak it just a little bit. So you won't have that cost involved with an expensive steel mold that you have to try and change. Changing a steel mold is very costly and it's not very time sensitive. So changing a steel mold, or let me back up, making a steel mold for something where you may not have the design 100% like you want might not be the right choice to make. You also want to choose the right material for the application. This is where our product services group can come help you determine what the right material for the application is. There's a multitude of tests that we can perform through R&D that can come up with a material that best fits the application, and then we can look at using that material for the precast shape. Lastly, you want to understand that the time commitment that it takes in developing that first shape. Initial time commitments can take up to 8 weeks or maybe even 10 weeks, depending on the application and the number of shapes involved. If you're going to make a steel mold, right now steel molds are taking anywhere from 4 to 5 weeks to get made, depending on the complexity of it and the size. And then it's going to take another 2 or 3 weeks to get the shapes made through the dry out process and put on a truck to be delivered to your facilities. So you need to understand that there is a time commitment in getting into a precast shape. If you have an application where you want to get somebody in there to design a precast shape that you're going to need for a shutdown in 2 weeks, maybe a precast shape is not the right thing for that application. It may be that it's the right thing for the next job, but if you're looking at doing a job in a very short amount of time, then we probably don't want to be trying to design that and get everything through the system with only a 2 or 3 week lead time. It's not to say that we can't, but in most applications or in most instances, it's going to be difficult to do that. So allow time for the development of the shape, to get the molds, to get the first shapes to you, and that'll make you more successful when you switch over to a precast shape. So now that you've decided, you've got your shape in-house, you're wanting to commit to using precast shape, then the next thing to do is to contact your Allied sales representative to schedule the installation. We are committed to being there worldwide with refractory solutions for your needs. And even though in today's environment that's become a little bit more difficult and we have to plan a little better, in order to make that happen, we're still committed to being there whenever needed. So with that, we'll move on to questions. I think there's several that we have here, so I'll look at them here. I'll read them out loud and then try and give you an answer. We also have some other people on the panel here that we may ask to chime in. We've got Doug Doza, as well as Tony DeSea, Tim Hoyt, and Pete Satchery that can chime in on anything. So let's look at the questions we have. What is the largest shape that can be produced in weight and length? And can complete furnaces be precast? It's a great question. The largest shape that we've made here in Columbus is roughly 10 ton. It was 19,000 pounds and change, so just a little shy of 10 ton. In Columbus, we do have two large bridge cranes that have 2 10-ton trolleys on each. So we have a lot of lifting capability here. We also have the capability to back a truck into the facility so that it can be loaded with the crane instead of loading with a forklift. So we can make some very, very big shapes. We can also make some very small shapes as well. So I guess another part of that would be what's the smallest shape we can make. And you know, we've made shapes quite frequently that are just a few pounds. So we have a wide variety that we can manufacture. Can complete furnaces be precast? Yes and no. It's going to depend on the furnace. If you have a 65-ton channel furnace that's melting iron, then can we cast that as a precast shape? Probably not. But we do have a lot of success with non-ferrous alloys, upcast furnaces for copper, where we do go in and install a shape system. So we do have shapes that are precast shapes that are going into a furnace, but it's going to depend on the furnace itself. So I guess a good way to answer that question is get a hold of us, and we'll look at the application and let you know. Another question here says, when you say precast, is it dried or pre-fired? If so, what temperature? Yes, it is pre-dried. As we mentioned earlier, it can be taken, the standard dry out is going to be somewhere in the neighborhood of about 800 degrees Fahrenheit. We can also go to 1100 degrees with no issue. And then in Columbus, we can also go to 2250 degrees Fahrenheit for some shapes. Next question is, how are shapes lifted into place? That's a great question. We want to make sure that we're, number one, lifting shapes safely. If it's a shape that weighs 25 or 30 pounds, then obviously that's not as big of a deal as if it's a shape that weighs 2,500 or 3,000 pounds. But many times we use embedded lifting couplers, a coupler with a loop on it. We also have applications where we cast coarse threads into the refractory itself. In those situations, you take the eye bolt that screws into the refractory, you grease it up, screw it into the refractory, and then once that eye bolt is removed, there's no longer any embedded metal that's left. There's also lifting devices that we can work with. We have some commercial manufacturers of lifting devices that we work with to customize lifting solutions for, like, a precast crucible, for example. So there are many different ways you can lift them. The main thing we want to make sure of is that we're doing it in a safe manner, number one, and we're doing it in a manner that you can use in your facility. So we want to make sure that those things are met. Next question is the only limitation to high firing embedded steel lifting devices or associated steelwork with the shape? And then, does high firing increase the strength of the shape or weaken it in the long run? So the first part of that question, what they're asking is the only limiting factor to high firing a shape whether or not you use an embedded metal lifting device or lifting coupler? Probably not. We're probably going to look at the application itself. We also want to look at the material. Obviously, if you do have an embedded metal lifting coupler, it's not going to be something that we can pre-fire up to 2,250 degrees, or what we would call high fire. So if it does have that embedded metal, we're not going to be able to do that. In a lot of situations, if it has embedded metal, or if it's a shape that has a steel backer plate, we're also not going to take it to 1,100 degrees Fahrenheit. You can have a lot of situations where the expansion of that metal can be detrimental to the refractory if you take it too hot, because in place it's not designed for the steel to get to that temperature, because the steel is a backer plate just used to maybe install the shape or give it the strength to be able to put in place. The second part of that question was, does high firing increase the strength of the shape or weaken it in the long run? That's another great question. That's another question that's going to be dependent on the material. In a lot of cases, if you go to 1,100 degrees Fahrenheit, you're actually better off if you don't go to 1,100, or if you go one up to that high fired temperature. Some materials can tend to be stronger in that lower temperature range, as well as stronger in the higher temperature range. But if you get into that range where the colder bonding mechanisms are no longer valid, then you have to be careful. Some materials will develop a ceramic bond at the higher temperatures. So in those situations with those materials, you could be looking at higher strengths if you go to higher temperatures. So again, it's going to be material dependent, and it's just something that we would have to look at and consider. What general tolerances can be held? Another good question. Our standard tolerance on a precast shape is plus or minus 1/8 of an inch. So roughly about plus or minus 7 millimeters. Less than that, 5 millimeters. So that's the standard. As long as we know up front if there is a tighter tolerance that's needed, then we can take the necessary steps to make the molds to meet that tighter tolerance. So I guess the best way to answer that is plus or minus 1/8, but it also depends on the mold. A steel mold, when we manufacture or have the steel mold manufactured, as long as we know up front that there's a tighter tolerance needed, then we can plan for that. With styrofoam, the tighter tolerances are a little bit more difficult to maintain, as well as with wood. And in some situations, we've had molds machined where we need to really maintain a tight tolerance. Does the lightweight backup dry vibe have a binder? Some do, some don't. It depends on the dry vibe material that you're asking about. Backup materials, a lot of backup materials are designed to not get hard under normal circumstances, under normal heat conditions. But if metal would happen to get through the shape, then they're designed to frit around that metal fin and seal it off so that it doesn't become an issue. We want to make sure that when you use a dry vibe backup, one of the things we try and keep in mind is the tear out. If you have a dry vibe backup that has a lot of bond in it, then it's going to be more difficult to tear out. So we want to make sure that we're using the right material for the application. Can we use precast refractory for induction furnaces? Yes. It's going to depend on the style of induction furnace. We make precast crucibles for induction furnaces. There's in cordless induction furnaces, there are structural components that we make a lot of. The top rings, the bottom rings, the pushouts. In the style of furnaces, what I refer to as the transite box furnaces, they have a precast top and bottom. So yes, we can use precast shapes in an induction application, and you can also use needles in an induction application. Our R&T group has done a lot of testing to determine just what concentration of needles you can use in an induction field so that you don't have issues with the needles coupling. So we have a lot of knowledge in that area, so you can use needles in induction. Obviously, it's going to be limited, but that is something that we do a lot of precast shapes for. What is the out of special? Let me see if I can read this right. What is the specification percentage, and what are the processes in place to minimize mistakes? So let me think about this. I'm just trying to figure out exactly what you're asking here. Oh, okay, I see what you mean. What is the out of specification percentage? So basically, you're asking what is our scrap rate? We want our scrap rate to be very, very low. We do have QA processes involved so that if we do make something that is out of spec, we want to find out that mistake happened here and not in the field. So if we do make something that's out of spec, then it will be caught in our QA process. And if that happens, then it's going to be a situation where we have to remake the shape. In making a precast shape, a big drawback, I guess, for a manufacturer is if you make a scrap precast shape, unfortunately, there's not much you can do with it. It typically becomes landfill, so to speak. From a customer perspective, if you do a cast in place lining and it's out of spec, or maybe the form shifted, then you also have a situation where you may have to tear the lining out and redo it just because something happened. So with a precast shape, I don't know what our percentage is. It's probably very low. I'm going to guess I'm going to hope that it's definitely lower than 1%. Doug, if you want to chime in here, and if you know what that true spec might be, feel
Yeah,
free.
Brad, it's significantly below 1%. And the key when it comes to the quality control in the process is you do all the inspections at the mold assembly area so that you don't create a shape that's out of specification. You verify tolerances at that particular point.
Good answer. Hopefully that answers the question that you had there. Next question, how does the surface finish of styrofoam compare with steel or wood? With styrofoam, you are going to have a surface finish that mimics what styrofoam looks like. The standard styrofoam that we use in-house when making molds is a 2-pound density. So it's going to have that texture of styrofoam. It's not going to be as good as steel or machined. And it's definitely, it's not going to be as good as wood or maybe a wood mold that has a silicone rubber face on it. So the styrofoam is a little bit rougher texture. If you have an application where you have to have a super smooth finish, we do have some coatings that we can use over top of the styrofoam that can give you a much smoother finish, but that coating is difficult to use and can typically only be used on a somewhat flat surface. So if you have something with a round bottom, for example, it's going to be more difficult to put that coating on the styrofoam because it's all going to want to run to the bottom. So we can use it, but it's limited as to where we can use it. Is the normal binder a calcium alumina cement, and are other binders used like colloidal silica? What is the advantages and shortfalls? Doug, I'm going to have you chime back in here since you're the R&D guru. So if you want to answer that question, jump in.
Hey, thanks, Brad. It's actually an excellent question. The predominant shapes we produce are calcium aluminate cement bonded. But with that being said, we make a number of cement-free systems. And we look at the shape or, frankly, the refractory application from a failure mode perspective. And where the binder system is part of the failure mode, or simply said, being attacked by the environment within the refractory application, we look at cement and cement-free options. When it comes to cement-free systems, we use colloidal silica systems, we use other silica-rich binder systems, we use phosphate binder systems, clay, alumina, and so it comes back to there are many opportunities when it comes to precast shapes to use a binder system that is optimized for the process. And that goes back to Brad's presentation. We look at the process as a whole, and the binder system is part of optimizing a precast shape for a given refractory application.
Thanks, Doug. Appreciate it. Next question from Ricardo is, during shipping, what is the risk of shapes breaking, and then can a broken shape be repaired? There's always a risk when shipping a precast shape for something to happen during transit. We try and package shapes. I've always used the philosophy with the guys in our shipping department that you have to think about a precast shape beyond our doors. So when we package that precast shape, we want to package it in a manner so that it will arrive safely at your door. Now, can something happen during transit? Absolutely. We've had shapes that have arrived where they've gotten knocked over and busted. So there are things that can happen during transit. The second part of that question is, can a broken shape be repaired? It's going to depend. If I'm shipping you a ladle, for example, that's going to contain molten metal, and that has been knocked over and had, basically a big break put in down the sidewall, that's going to be below the melt line, then absolutely not. That's not something that we would advise on repairing. We would rather replace that shape. We will work with the trucking company to make a freight claim to get that shape replaced and get you one that everybody feels more comfortable with using. Now, If it's something minor, if you have a shape that shows up and a little corner's broken off or something like that, that's not really a structural component or going to really affect the performance of that shape, then it could be repaired. You can use Foss bond castables in a lot of situations to make those repairs. Plastics, rammable plastics, but for the most part, if it's a damage that's occurred that we feel is going to be detrimental to the performance, then we would just much rather get it replaced. Lee asked a question, is hard water a problem with castables? Pete, you've already addressed that on the chat. Pete's answer was, in general, for castables, using potable water that's suitable for drinking with a pH value between 6 and 7.5. It's not an issue, and of course, it's not an issue with precast shapes. With a precast shape, the water source that we use here is a potable water source. We've checked it, we've tested it to make sure that it falls within that pH range. pH of water affects set times of castables probably more than anything. Another factor in a set time of a castable is the temperature of the material before you mix it. So if you're located in the Great North, it's in February and it's very cold outside, and the material's been stored in a warehouse where it's not been heated. If that material comes over that you're going to mix is very cold, then you're going to have a very slow set time. It will set up eventually, but you're going to have a very slow set time. So those are things that we always, when we're doing cast in place situations in the field, that we always keep in mind. But the pH of the water is also a big factor in affecting that set time as well. Is the water quality controlled in the manufacture of precast shapes? If the answer is yes, then what are the controls that are taken into consideration? I think I just answered that. Like I said, we do use a potable water. Our water source at our plants are all coming from a local supplier of water. So it's here in the States anyhow, it's not well water or something like that. So it is checked periodically to make sure that the pH is what we want it to be. And then it's also checked by the supplier to make sure that it continues to meet the standards of a potable drinking source. So it is checked. In the beginning of the presentation, you showed a picture of a ladle. It looks like there was a precast shape at the top of it where the metal runs. Do you work with specific shapes to minimize localized mechanical wear? I think what you were talking about is there was a ladle there that had a spout affixed to it that was part of the shape. Do you work with specific shapes to minimize localized wear? Yeah, that's part of our design. If we know that you have a situation where you have localized wear, then in part of the design of that shape is going to be taking that into consideration and finding out if there's a way we can change that design to help eliminate that wear pattern. In a lot of ladles, we may incorporate an impact pad on the back wall or bottom of a ladle where the metal strikes all the time. So there are things that we can design into a shape that takes things like that into consideration. Do you have experience with aluminum transportation ladles? We do make shapes for aluminum. We make shapes for certain applications in aluminum, but we also have global partners that we work with on an exclusive basis that make precast shapes using the Allied product technology. So as far as this specific application for a transport ladle, it's something that we would want to look at and determine in that certain specific situation if it's something that we could do. So I guess my suggestion there would be contact us, get a hold of your sales representative. You can always contact me, anybody at Allied, and we would be more than happy to sit down with you and determine whether or not a precast shape is going to be right for that application. I've heard about your exact technology. What applications can this technology be used in? Exact technology is a technology that Allied come up with that developed a few years back, where we incorporate the use of a non-conducting belt, if you will, around the outside of a shape. Now that belt is embedded in the castable itself, and it is there to give hoop strength for the shape. So, for example, the main reason this technology come about was for two reasons. One, it was crucibles for induction melting, and it was also for use in silicon carbide rings that are used in the carbon to graphite industry. The benefit of the Exact really is all about keeping the material in compression during operation. It doesn't allow it to expand. If it doesn't allow it to expand, then it can really control the cracking that can occur. It's for induction melting, for coreless induction melting, it's mostly used with non-ferrous metals. We do have some tests going on for ferrous metals, but for the most part today, it's used in non-ferrous applications. With aluminum, for example, with aluminum, you're right there on that level of expansion and contraction when you're operating. Aluminum is going to go molten at 900, 950 degrees Fahrenheit, and your typical operating temperature is going to be, 11 or 1200 degrees Fahrenheit. You're always right there in that area of expansion and contraction of a refractory. When refractory gets above 1,000, 1,100 degrees, it expands. When it cools down to 800 or 900 degrees Fahrenheit is where it starts to contract. So with a coreless induction furnace melting aluminum, you're always in that area. So if you, especially if you're running if you're tapping the complete melt out, if you tap out, charge your furnace back, by the time you get molten metal back in that furnace, the lining's already cooled down below the point of contraction. So the Exact technology is really designed for applications like that. It's going to hold it in compression so that it can't expand much, therefore it can't contract much, and it's going to keep the refractory from developing cracks, which can lead to thinning issues. So that's where it's used at the most. Now, there are other applications where we are looking at using it, but again, you have to keep in mind that the use of Exact technology is designed around hoop strength of refractories. If you use a push-out shape for an induction furnace bottom, can this shape be reused? I assume what you're talking about is a push-out plug. Yes, they can be reused. We make several precast push-out plugs for various customers. They should be able to be reused if they're designed correctly. We always like to use the addition of stainless steel needles up to a certain point. That is something that's going to be in an induction field. So you have to be cognizant of how many needles you're going to use, but it is something that we do quite a bit of. So yes, they can be reused. They're typically on a steel plate, as long as there's no damage to the plate and the function of that plug is there's no issues with it, then it can definitely be reused. Looks like the last question we have is there an ideal additive ratio for steel needles if required, and is there a limit? That's a great question. Is there an ideal ratio? It's going to depend on the application. I've always been a believer that if we're going to use steel needles in something, then you need to use an amount of steel needles that's going to be beneficial. I like to think that amount starting point is somewhere around 2.5 to 3%. How much needles? What's the maximum amount of needles that you can put in a mix? That's going to depend on the mix. Our metal rock line has a very high percentage of needles in it. It's a proprietary amount that we kind of hold close to the vest. It's a great product that we sell a lot of as a precast shape. So it's got a very high concentration. So the limiting factor on how much, what's the maximum amount of needle that you can use, it's going to depend on the material, it's going to depend on the process, and it's going to depend on the application and what the maximum amount you can use would be. So it looks like that's the last question that we have. I don't see anything else. Elise, is there any other questions that I've missed?
Nope, I don't think so. I think you covered everything.
Okay. Well, if there's no other questions, that I've missed, then I want to thank everybody for joining us today. If you think that a precast shape is something that you want to look at, then by all means, contact us, contact your local sales rep, and we will be more than happy to sit down with you and evaluate everything to determine whether or not precast shapes are going to be something that makes sense for your operation. Also, there's going to be a survey that is sent out to the email address that everybody used to register with. It's a real quick survey. I think there's maybe 2 or 3 questions on it. We just want to find out, how we did today. Did we answer all your questions? So if you could take the time to answer the few questions on that survey, it would be greatly appreciated. And for anybody that's wanting to know if this presentation will be available for you to show maybe somebody at work or somebody we are going to have this posted on our social media accounts. We'll have in a few days, we'll get a video put up on YouTube that will be something that you can download and show to people. So come back and view those, share them at your leisure. And if you have any questions, please contact us. We would be more than happy to help you out. So thank you very much for joining us today. And everybody stay safe. Have a great day wherever you may be. And thank you for joining us.
Thanks, Brad. I just want to add one more thing. Just as a heads up, we will be having another webinar at the end of July. We'll have more information on that on our website and LinkedIn in the next coming weeks. So just make sure you check back there and sign up whenever we get the sign up. So thank you everybody for attending.
Thanks everyone. Have a great day.